Butanol, C4H9OH, is commonly used as a lighter fluid. Consider the combustion of butanol in the presence of oxygen gas. If 3.425 grams of butanol react with 3.555 grams of oxygen, what mass of gas is produced? What mass of the excess reactant remains after the reaction has gone to completion? First, before we can do anything, we have to balance the equation. So we're going to write out C4H9OH, which is a liquid, plus O2 gas, reacts to form CO2 gas and H2O gas in a combustion reaction. To balance the equation, we're going to put a 6 before the O2, a 4 before the CO2, and a 5 before the H2O. So now that we have our equation balanced, we can start our problems. So first we're going to go over what we're looking for. We're looking for the mass of CO2 produced and the mass of excess reactant produced. For this problem, we're going to assume that CO2 is the gas. So first, to find the mass of the CO2 produced, we have to find the limiting reactant. Before we can find the limiting reactants, let's write down what we know. So we know that we have 3.425 grams of butanol, and we know that we have 3.555 grams of oxygen. We also know that the molar mass of butanol is 74.121 grams per mole. The molar mass of oxygen, or O2, is 31.998 grams per mole. And we know that the molar mass of CO2 is 44.009 grams per mole. Because water is not involved in solving this equation, we're just going to leave it be. So we're looking for the mass of CO2. To find the limiting reactant, we'll be doing this in 2 steps. First, we will start with grams of butanol, and we will change it from grams to moles. Then we will use the molar ratio of butanol to CO2 to convert from moles butanol to moles CO2. Then we will convert moles of CO2 to grams of CO2. And we get 8.134 grams of CO2. And then we will do the same process for oxygen by starting with grams of O2, which we already know, converting from grams to moles of O2, and then we'll use the molar ratio of O2 to CO2, and then we will convert from moles of CO2 to grams of CO2, and we get 3.26 grams of CO2, which, because it is the smaller value, that means that oxygen is our limiting reactant. Because we know that we cannot make more CO2 than our limiting reactant allows, we know that 3.26 grams of CO2 are produced. And that will be the answer to the first part of the question. Next, we will find the mass of the excess reactant. To do that, we'll start with the mass of O2, which is our limiting reactant, because we will use that to find the amount of excess reactant used, and our excess reactant is butanol. Then we will convert that from grams of O2 to moles of O2. And then we'll use the molar ratio of O2 to butanol, and we will convert from moles of butanol to grams of butanol, which gives us 1.372 grams of butanol. And then we will subtract from 3.425 grams, which is our original amount, of butanol, 1.372 grams of butanol, which will give us 2.055 grams of excess butanol, which is the answer to the second part of our question.